Today we wanted to actually make this real, and I want to go through 20 use cases of metadata in real life that we see. So first, taming the service requests from chaos to calm. Like, the core challenge that data teams have is we deal with service requests all the time. Let's take analyst service requests. What does this metric mean? How is it different from metric Y? I want to see metric X by geography instead of segment. Can someone confirm if this is the right way to join these tables? One of our customers, leading mobile esports platform, they have like 90 million users. Their analyst team, 80-member analyst team, they figured that they were spending 40% of their bandwidth addressing like ad hoc data requests. That's like half the team basically spending all their time answering questions like this. The core thing that metadata can help you do here is actually go from service requests to product. So as you start thinking about each of these service requests, how do you make these service requests reusable and reproducible? So this team, they basically started thinking about each of these requests as internal, reusable, reproducible products for their organization. First, their data assets itself. How do you make that reusable? You know, what does the column name mean? Is this updated? Like, you know, we have these like asset profiles. Like, think of like a GitHub code repo, right? When you onboard an engineer, you just share a link to a GitHub repo. It has your code, your documentation, your revisions, everything in that same space. How do you do the same thing for your data? The same thing with metrics, right? Each of your metrics, if you think about it, annual recurring revenue, how do we define customers? Each of these can be reusable, reproducible assets for the rest of your organization. And the third is their queries itself. Every analyst I've spoken to at some level has this like notepad file on their desktop, and it basically has these SQL snippets in it. Yeah, right? And so that could be reusable and reproducible. So basically, those just turned into links that now can be shared with other folks inside the org, which in this case, they actually, just by doing these three things, 43% analyst time was saved. So basically, they have double the team to execute on their projects next year without hiring one extra person. So like service requests for analysts, our data and analytics engineers deal with a ton of service requests as well in their day. Data SLAs, is this data updated? Do we have this data? Do we actually ingest data from our survey tool into our warehouse? How are the columns in this table derived? So extending that same data as a product concept, you could actually start thinking about, and so we've had customers who've actually brought in context that a data engineer needs as a part of these data as a product request, right? So these are typically Airflow SLAs that are auto-updated. This is stuff like freshness that come from DBT tags, automated column level lineage that brings this together in a way where we had one customer, they were a B2B e-commerce platform, and they actually started measuring, they started measuring Slack messages. And their core KPI was like, we want to reduce the number of Slack messages that our data engineers and analytics engineers are dealing with. And they found that there was a 80% reduction in Slack messages that their engineers were dealing with, just by, again, making these reusable and reproducible. The third use case we see alongside this is just speeding up data team onboarding and ramp. On average, an analyst typically spends 18 months on the job. It typically takes them 6 months to onboard inside an organization. One of our data teams, leading insurance company, they reduced that time, like basically they reduced almost all that time by making these assets reusable and reproducible inside their org, right? So how do you help new joinees ramp and get productive as quickly as possible? Quick shout out, this is why we're so excited by what DBT is doing with the semantic layer and what this means to data teams. Metrics is in some ways the language of the business. And for the first time with the DBT Atlan integration, in some ways, you're now able to bridge this gap between the language of the business, which is typically where the service request almost always starts, and actually bridge it back to your data layer and bridge it back to your physical layer. So metrics now are a first-class citizen in Atlan. Every metric has an asset profile, which has 360 context about the metric. Who owns it? Where does it come from? Which team does it belong to? And full lineage all the way back to source. So if you have a metric, let's say revenue, You're able to measure it all the way back to the source Postgres database that's actually creating or feeding in that metric. So that question, what does this metric actually mean? How is it derived is now no more something that you actually need to do as a service request inside the org. Next, going from doubt to trust. Proverbial question. Number doesn't look right. Who's faced this? That answers it for itself. Now, the problem with this question is that it actually seems like a really simple question, but only data people know how complicated answering this question actually is. So we had a data team that actually mapped this out as to when there's a metric issue, what actually happens. And they're like, we go into Looker and we check if the metric calculation changed, and then we go to Jira and we see if there was any expected calculation logic, and then we go to Slack and then we ask a question, and then we go to LookML, and then we go to anyway, it's I actually asked a question of someone in our team saying this seems really complicated. Is there a way I can simplify this so that people can understand the slide? And then, I couldn't, which explains how complicated answering a simple question what does this, why is this number wrong, look like? And so that brings us to the next set of use cases, speeding up root cause analysis. Data teams spend a ton of time just figuring out what went wrong. And if you have automated column-level lineage that goes all the way from your source to your end BI, a bunch of those steps, if you go back to this, there's a bunch of steps where people are going into Looker and seeing what happened there, and then they're going into your DBT and seeing what happened there, and then they're going to the source and seeing what happened there. That basically can actually get relatively simple. We had a team that actually saved, they used to take 6 hours for every single RCA request that happened in the org, and that went down to 10 minutes just by speeding up these root cause analysis requests. Now, this comes to the exciting part. One, something went wrong, but how do you actually start preventing things going wrong and prevent breaking changes? There's been a lot of talk about data contracts recently in the ecosystem. The way I think about data contracts is that, the first step is knowledge. Developers don't want to break stuff downstream, but they don't even know that when they're making a change, what it's actually breaking for us as data teams, right? So some of the use cases that we see, so on the right, you actually see this is a screenshot of Salesforce all the way down to your final BI layer. And you can start empowering your developers and RevOps teams to say, if I make a change in this object, what is it going to affect downstream for us? So end-to-end source to BI lineage, visual impact analysis, just first start empowering the data producers that data teams work with the context that they need to, they probably don't want to break stuff. No one wants to do that, and some of the interesting use cases we're starting to see is starting to actually integrate this into your CI/CD pipelines naturally. So when you're actually in a CI/CD pipeline, integrate a metadata API into the CI/CD process, see what impact it's going to create downstream, before a change is actually pushed into production. Something that we spend a ton of time thinking about in Atlan. So far you saw a lot of the use cases that metadata in general can power. Some of the things that we spend a lot of time thinking about is how do you actually go from this metadata being a repository for knowledge to actually starting to activate this to create automated actions inside your organizations. This is an example of active, trust management inside your org. So we have a customer that uses a data quality tool which generates anomalies. The anomaly basically obviously comes at the physical layer, so this is a table that had an anomaly that was detected alongside it. What they do from there is they actually have an automated action that connects those announcements to the physical assets, the downstream BI assets, because now you have lineage, but also the metrics that those tables are actually connected to. And they actually have logics built into this. So the logic basically goes, if it's a metric that's powered by 5 tables and more than 2 tables have an anomaly that's detected alongside it, mark the announcement as a high warning signal, red, don't use this metric right now, and take that back to their BI tool So when your BI consumers are actually using this data, they have that context built in right then and there. So these are some of the use cases of metadata where you can go from humans starting to take action on your metadata to systems automatically starting to take actions with your metadata. Some other use cases here, I'll go quickly, but active change alerting works very similarly. But if there's a change upstream, there's a change in the way Fivetran's loading your data, again, that same change alerting announcement auto-propagates all the way down to all your data team members, but also your business consumers. This is, data platform migrations. We migrate things all the time. How do you assess the complexity of the migration? How do you create deprecation notices, change notices, make sure that nothing breaks when you actually migrate stuff? My third emotion, anxiety. This was the worst emotion that I had to deal with. And so how do you actually start going from anxiety to just a state of peace and calm? First, just managing security classifications inside your org. We have a ton of classifications. We have right from things like PII, GDPR, but we also have things like financial reporting data that you don't want anyone to touch, and we had HR data, which you probably don't want everyone in the company to be able to see, right? So take the same use case of propagating announcements to create trust and think about that from a security perspective. We had a leading fintech that was applying for a bank license. So they basically had to create confidentiality, integrity, availability ratings, which would determine if they get their bank licenses or not. And so what they were able to do was basically say, here, in their final business semantic layer, they basically created these tags for confidentiality. And then they used lineage to propagate it back all the way down to every single column that could be potentially creating that, right? And this is a live system that's changing over time as you're managing it. Again, going back to active use cases, these are some of the use cases that we're super excited about. There's a Fortune 100 tech company have a data lake that actually powers a customer experience platform. So it's basically not a human even looking at the data anymore. This is live stuff that's happening, which means that if something goes wrong, it's actually kind of not so good. Hundreds and thousands of change events happening every single day, adding a column, updating a column, classification tag changes, obviously dealing with user data in this case. There was no notification mechanism for their security team or their engineering team. So their security team was constantly in reactive mode when something broke, and there was a ton of business risk actually when something changes in a live platform that's affecting your customers downstream, and it wasn't the change that you want to happen. Something we're doing at Atlan is opening up metadata change events now through a Kafka queue. And we're starting to see customers build some really interesting use cases of these. So in this case, metadata can start triggering actions. So the actions on every change event that happens upstream are, in this case, there's a change, there's a chat notification, it opens a Jira ticket, and it automatically triggers a data quality test suite to actually check if the change events are okay, or if it should trigger something else as a downstream action. And starts being able to actually answer a ton of what used to be a very human manual process with tons of meetings, now actually become a completely automated queue, controlling a bunch of different tools in the stack, right? So you can see data quality tool, Jira, your data lake, your bunch of different tools actually come together through that unified metadata action layer in some ways. Programmatically archive data. There was this very interesting use case of a media monitoring company buy a ton of external data. External data basically comes with requests on when that data should be deleted contractually. And the way they managed it was that there was an Excel sheet and there was a bunch of program managers that were assigned to remember that this data needed to be deleted. But the program managers couldn't actually action on it because typically they would reach out to the analysts or the other teams. Sometimes they actually missed deleting the data at the time that they should have. So that's literally actual risk and contractual obligations of the company. That's something that actually can now be an automated action, right? At the time of signing the contract, the metadata field on when it should be deleted. In this case, there's a notification when it arrives on the data lake that goes directly to Slack as an automated action. It creates a Jira ticket 30 days before the contractual end date. And then this basically, right now that they're taking that final deletion as a human step. So then the human basically decides whether they want to delete it or not. But technically, you could actually start saying, hey, if this is not being used or it's not a popularly used data, auto-archive this data set downstream. So these are the kinds of use cases that we're starting to see. And again, going into being able to create that system of peace, right? Data access management, who accesses data where, compliance and audit reporting, tons of audit requests across your data landscape in some ways. And then data deletion requests, like if you have to delete, you actually have to delete a data, like a request that comes from a consumer, how do you actually track across your ecosystem and make sure that it's actually deleted across time? From pain to comfort, saving money on that warehouse bill. There are actually a ton of questions that can help you optimize your data stack spend in some ways, right? Which queries are taking too long to run? Can we deprecate these tables? How long are jobs waiting to execute? Which tables are being used in BI tools? What are the most or least queried tables? All of this is generating metadata live in your ecosystem. A leading life insurance startup, they actually end up saving over $200,000 annually on their warehouse spend just by being able to leverage all of this metadata and figuring out how to better optimize the usage of this. Some of the things that excite me the most with this connected ecosystem are almost this being able to create the perfect experience for end users, right? So if you know that 90% of your users log in on Monday morning at 10 a.m., you should be able to auto-scale up your compute clusters, like at 10 a.m. And you should you should be able to make sure that your pipeline updates at 9:45. And 2 hours later, when people actually log out, you can auto-scale down everything, right? So there's this interesting balance between spend and end-user experience and performance. And if you have metadata across your entire ecosystem and start driving actions alongside this, you can actually orchestrate your data stack to be able to create the best experience for your consumers and at the same time not have anxiety because of those crazy bills sometimes. And finally, from disillusionment to joy, metadata helps every one of us do our work better, right? Like knowledge, context. If you think about all our jobs, every one of our jobs in a data team can be done better if we have the right context alongside it. So some of the use cases that we see is, again, how do you take that context and make it available in the tools that people are using on a daily basis? So what you're seeing now is an IDE, and in the IDE, you can start seeing things like recent joins that someone's done. Is this a popular table or not? Who owns it? Is there an issue that's associated with this table? So should I use this at all right now or not? What does the metric actually mean? What is the column description? And so right then and there, as you're doing your work, you're able to, all that context switching between like a bunch of different tools can actually start going down inside orgs. And then finally, taking that not just from our data team and driving that final dream that I guess a lot of us work towards, right? Like, which is how do you actually help the business drive self-service decisions, right? Can I trust this data? What does this metric mean? Who can I reach out with about this metric? So what you're seeing on the right, that's actually a Tableau dashboard with an Atlan widget that's actually showing all the metric context that's coming from dbt, semantic layer, right then and there in the dashboard. So essentially what you're able to see is, here's the metric, here's how we define it, that's powering the dashboard, but it's also bringing in who owns it, lineage, is this updated, is there an announcement that's associated with it? So when someone's in that final business layer and saying, can I trust this data? They actually get that answer right then and there without having to reach out to anyone else inside the org. So I thought a lot before putting together the 20th use case here, and I actually there's a ton more use cases that I can cover. But the thing that I wanted to talk the most about, and this is, data teams, when they come together and work together as a dream team, they can go on and do amazing things. So when we were a data team ourselves, after those 2 years of changes and changing those emotions, One of the most beautiful things that I saw happen was our team came together to build India's national data platform, which is the largest public sector data lake of its kind. It's used by the Prime Minister and all of that, so it's very cool. But what was really cool about that project was it was built by an 8-member team. In 12 months, it was one of the fastest of its kind globally. 4 of those people had never pushed a line of code to production before. It would never have happened if we hadn't found a way for those diverse people. There was an economist in the room, there was a machine learning engineer in the room, there was a geospatial scientist in the room, there was a data engineer on the room, there were analysts in the room. If we had not found a way for that team to come together and become a dream team, like we would never have been able to pull it off. And that's really the reality of our data teams, right? In data teams, diversity, it's not a bug, it's a feature. Like diversity is the only reality in our data teams, right? We have diversity in people, analysts, engineers, analytics engineers, scientists, business users, machine learning researchers. I can go on for like the number of different kinds of personas. Each of these people have their own diverse tools. They have their own, BI tools, Slack, Jira, GitHub, each of these tools create a diversity of data assets. We use notebooks, we use tables, databases, like models, like projects. And all of us are different. Like we have different, use cases and data stacks and maturity and complexity. This diversity is the only reality that exists in our teams. This diversity is our biggest strength. When we're able to harness this diversity together, without this diversity, data projects will never be successful. But it's also our biggest weakness. It's why it becomes really hard for these teams to work as a dream team. It's why it becomes really hard for building trust between, like no other team has this kind of diversity, right? Like think about a sales team. Pretty much everyone's similar. They understand each other. They have the same language in a way that a data team just doesn't. And so if you're able to turn this into our biggest strength, data teams can go on and do amazing things in the world. We believe that metadata can be that glue. Data about our data can be that glue that binds together these diverse teams and tools and people together to actually help us create those dream data teams in the world. And if data teams go on and, if you think about the next decade, every amazing thing in the world, like self-driving cars and man on Mars and the cure to cancer, like there will be data teams that make that happen. And if we can make those data teams dream teams, we can actually change the world. So yeah, with that, thank you.